My name is Derrick Hao Zhe, and my task is the 2324A for the past year question, and the part A for question 1. What will happen? What will happen to the diffusion region when p-n junction is followed by it will become narrow and thin. So question 2. Identify one application of Zener diode and one application of regular diode in the DC power supply system. So for the Zener diode is voltage regulator, and for the regular diode is the halfway rectifier. So determine the diode and light bulb condition in table 1 based on the schematic. So we can see the diagram. So when the V bias is 10, so it will close the diode because the diode is 0.3 or 0.7, so it will close the diode, so the light bulb will on. And for the 0 and the -5, it will cannot close the diode because it's smaller than the voltage of the diode, so the light bulb will off. So this is the part B, question 1. So we need to use the Derrick method. So we short the voltage. And we open the diode, so we will get a series circuit like the red circle. So then we can calculate the series resistor, so we can know the V is 400 and it will equal to the V diode. So we get the we use the voltage divider and we get the 1.6 volt. So 1.6 volt will be our total supplier, and we need to get the RL. So we use the 100 and use the 600 and 400 to parallel, and we get the plus the 100 and we get the RL, so we get the 340. So when VD equal to 0, so ID equal 1.6 over 340, so we get the 4.71 milliampere. And when ID equal to 0, our VD will equal to VS, so we get the 1.6 volt. So we plot the graph, then we can find the operating point. So we get the 2.2 milliampere and 0.6 volt. And for the question 2, we need to calculate the static resistor. So R equal to V equal to IR, so R equal 0.x6 over 2.2 times 10 over -3. Then we get the 390.91. So explain what happened will be the Q point if V1 is increased. So when V1 is increased, our VDQ will increase and IDQ will also increase. This is the question 2. So we can see this is so we need to draw the waveform at Vx when switch A are open. So label the minimum and maximum voltage value for two complete circle. So we know the VRMS is 240. So we use the formula to calculate the V secondary. So Vx equal y over x Vp, then we get the Vp equal to 339.4112. So the Vp, after we get the Vp, so we can calculate the V secondary. So we get the x4 X5 2X. Then we use the KVL. So VD3 plus VD2 plus Vx minus Vsec secondary equal to 0. So when we use the positive circle, so when Vx will get the 83.4452x. So now we need to calculate the difference between the V maximum and V minimum. So we can use the formula Vx over 2FRC. So after we substitute, then we get the 8.3452x. So we can get the V minimum, which is the 75.1075. Then we draw this graph. Okay, after draw this graph, then we get the question B. When the switch A is closed, then we need to determine the range of operating Zener current Isaac. So now we know the V is 83.452x. So V is larger than the Vz, so it's on. So we know that the V maximum equal IR plus Vz by using the KVL. So we substitute and we can get the I maximum, which is 31.32 milliampere. Then we use the Kirchhoff law. Then we get the IL is 20 milliampere. Then we also calculate the V minimum, which is also using the KVL. Then we substitute, then we get the I minimum is 27.55 milliampere. So after using Isaac, for Isaac we can use the Kirchhoff law also. Then we substitute and get the 11.72 milliampere. Also for the 11.32 milliampere is for the maximum current. So for the minimum current, then we get the 7.55 milliampere. So if Isaac max of the diode Zener is given as 30 milliampere from the data sheet, explain what will be happen to the diode Zener operation if RL is removed. So when the RL removed, our IAS is equal to Isaac. So then we know our Isaac is 30 milliampere. Then our IS is 31.725. So when the IS bigger than the Isaac, then our diode will damage. Okay, so thank you.